We're not quite done with the Grignard reaction, but I want to take a quick break of the Grignard reaction and just start our official unit on alcohol. So I'm going to briefly discuss alcohol chemistry in this video, or I guess alcohol physical properties mostly, along with some discussion of naming and that sort of thing. So we have kind of a new functional group, the alcohol, and let's kind of treat it appropriately. So the new functional group is the alcohol. There's a lot I could say about the alcohol, a lot I want to say about the alcohol, but we don't have time. So some parts of this module will be left for organic chemistry 2. That's okay. We'll see enough of this so that we can at least, get, at least see what we need to see in organic chemistry 1 related to alcohol. So first of all, naming or nomenclature. So naming and nomenclature. What we do is we take our alkane, take the alkane parent chain, replace ANE with anol. So replace ane with anol. So if we have this molecule, it is no longer, it has 2 carbons. It is no longer ethane, it is ethanol. Okay, and we should also include a number to indicate where the alcohol is. So the number in front of the parent to show where the OH group is. All right, so actually you don't see that too much with ethanol, but maybe for, definitely for like butanol, for example. So this is 1-butanol because we took the 1, 2, 3, 4 chain that's butane and we replaced the ANE with anol. That's in contrast to, 2-butanol. Okay. And we could have cyclic rings with these. We could have a methyl group and an OH group. So this would be 2-methyl, 1-cyclohexanol. And sometimes people leave the 1 off. Frequently people leave the 1 off, but you should, for now, let's include the 1. So it happens to be the case that when you number cyclic molecules, the C with the OH group is number 1. That's often the case. So you saw previously that we had a methyl group and we had an OH group. I could number this 1, 2, 3, all the way around to 6, or I could start at the OH, 1, 2, methyl group. We still have a 1 and we still have a 2 substituent. The sum of the numbers are the same, but it turns out that this is preferred because IUPAC likes to say that OH has a higher priority, than C. Hence the name that I provided on the previous page, 2-methyl, 1-cyclohexanol. Okay, some important molecules to recognize as we're, if we move on from the naming kind of quickly, some important alcohols are wood alcohol. Wood alcohol is methanol. which is CH3OH. Spirit alcohol is the alcohol that they put in alcoholic beverages or spirits, and that's ethanol. And then rubbing alcohol, that is isopropanol, where you have an isopropyl group attached to the OH. Otherwise, it is 2-propanol. Okay, so those are some important alcohols that we see everywhere in everyday life, especially now. As I'm recording this, we're in the midst of the COVID-19 pandemic. And rubbing alcohol is quite useful because if you add it to biological organisms, they die. So you see rubbing alcohol wipes everywhere. Ethanol is actually a little bit more effective. If you mix ethanol at 70% ethanol, 30% water, it will kill microbes very quickly and efficiently. So you can kind of spray it on a surface and the microbes you can assume are for the most part dead. Particularly that's helpful in molecular biology when you're worried about contamination from kind of microbes flying out of your mouth while you're trying to plate an agar plate or something. Wood alcohol, methanol, is also quite effective. However, methanol is as toxic as ethanol can be in high doses. We know that it's can be controlled and managed so that you get other effects. But methanol, it's not the case. So methanol is highly toxic. Our body cannot handle it well. A lot of really bad things happen if people consume methanol. They go blind. Certainly mental deterioration happens quickly, and oftentimes people just die if they consume too much methanol. So you don't see that used too much in sterilization practices because then you just have a bunch of methanol lying around that you have to deal with. But otherwise, ethanol, if you can afford to use it without worrying about people consuming it, uncontrollably, then it's quite effective. It evaporates quickly, but otherwise 2-propanol, you don't have the as much of the toxic effects as methanol. It turns out that the issues with some of the issues with alcohol that's produced in society, when we've had issues of alcoholic beverages produced in society, things containing ethanol, things would get really bad if we mix too much methanol in there as well. And so during Prohibition, for example, when the consumption and production and sale of ethanol was prohibited, people often had kind of moonshine equivalents, and moonshine often has a lot of methanol in it, and you would see people die from methanol poisoning. People that consume moonshine, you often see some mental deterioration. It's a bit of a stereotype, but yeah, moonshine is definitely bad for you because methanol consumption is horrible for you. And this was a really dark moment for the United States government, because what happened was they would spike some ethanol with methanol and be like, see, you can't drink it. And then people would be like, we could still drink it. We're just going to get really sick and die. It's kind of on you because you gave us, it's kind of on you, government, because you gave us the ethanol. Anyway, controversial topics. There's really great reads out there. I think the Poisoner's Handbook was one that I'm recalling that I read, where I have great history on Prohibition and related to the amount of methanol that's produced. Anyway, we'll talk about methanol and ethanol oxidation in future lectures and think about things like why do hangovers occur when humans consume too much ethanol. Okay, so those are some alcohols that I think it's really important to know. Like, you know what you're buying when you pick up isopropanol. You know why you don't want a big bottle of rubbing alcohol, wood alcohol sitting around your garage. It's also flammable. Okay, let's move on to some physical properties. So alcohols in general have a much higher boiling point than their alkane counterparts. Okay, and it's all due to hydrogen bonding. We've talked about hydrogen bonding before, but when you have hydrogen bonding, or what is hydrogen bonding? Well, it's when you have an acidic hydrogen atom that's attached to a non-carbon element, so there's generally a difference in electronegativity, unless it's attached to itself. So if we have a bond to oxygen, as in the case of our alcohols, we say that there is likelihood of hydrogen bonds forming between the delta minus of an oxygen of one alcohol and the delta plus of a hydrogen on the other. That interaction is a hydrogen bond. It's a fairly strong non-covalent interaction, very strong non-covalent interaction between molecules. And this will increase the boiling point. And so while ethane and methane are definitely gases at room temperature and propane is hard to control, when you add that OH group, things happen. That is the boiling point for, let's move this down. The boiling point for methanol, MEOH, is 65 degrees Celsius. Recall 23 degrees Celsius is room temperature, so you need some heat to boil away methanol. It's definitely a liquid at room temperature. We know ethanol is a liquid at room temperature. And then 1-propanol, not isopropanol, is certainly a liquid at room temperature. And so what we see is we have an increasing in boiling points. So we have 1 times carbon in the first example, 2 times carbon. So we see kind of 3 effects here. First of all, methanol boils at a much higher temperature than methane, and that's because of the OH group. And then ethanol boils at a higher temperature than methanol because we add additional carbon atoms and we have additional non-covalent interactions by way of London dispersion forces between the additional covalent bonds of our molecules. So it's that carbon effect. We add carbon, we see an increase in the boiling point. It looks like what, maybe about, it kind of depends on the situation. So 15 to 20 degrees Celsius, maybe, depending on how far you go. Anyway, those are some boiling points. One thing I'll note, though, is as you increase the number of carbons, you increase the boiling point, right? But what happens if you go to 0 carbons? If you go to 0 carbons, what I'm saying is instead of CH3OH, let's cross out that CH3 and replace it with a hydrogen with HOH. And now you're back up to 100 degrees Celsius. And this is for water. So water's boiling point is 100 degrees Celsius. You probably know that, but just put that in context. It boils at a higher temperature than the alcohol with 3 carbon atoms. Now I know water isn't quite an alcohol, but it's still just kind of an interesting trend. I like to say that, you know, the trend of adding more carbons increases the boiling point, doesn't hold water for water. Anyway, sorry, dad joke. Okay, full of them today. So, but the important thing is that the alcohols are all at least liquids at room temperature, if not solids with much higher boiling points. The last thing I'll mention is that alcohols are often called hydroxylated alkanes. Ooh, hydroxylated alkanes. And the OH is a, depending on who you talk to, hydroxy or hydroxyl group. That is to say, if you have a really complicated molecule, what you would say is that, ooh, that OH, that's the hydroxy or hydroxyl group. So it's a substituent on a molecule. It's called a hydroxyl group or hydroxy, kind of sounds like hydroxide. And it defines the molecule as being an alcohol. And so if it has multiple functional groups, maybe you just refer to that one position as the hydroxy group or potentially the hydroxylated carbon. Maybe what I'll do is I'll just do the primary, secondary, tertiary thing. Sorry, did you have enough time to write this down? We should consider what a primary, secondary, or tertiary alcohol looks like using what we know about primary, secondary, and tertiary nomenclature. So let's first of all start with our methyl alcohol. That's just methanol. But what about primary, secondary, and tertiary? Whereas methyl alcohol was a single example, methanol. Primary, what we're going to do in each of these cases is focus on the C with the OH. Make sure we're lined up here. The C with the OH. Okay, so for the primary alcohol, we're going to have one substituent on the C with the OH. Secondary, we're going to have two. along with one hydrogen. And then tertiary, we're not going to have any hydrogens because we need to fill that carbon up with 3 R groups. So a primary alcohol is an alcohol where the carbon attached to the OH group has 1 substituent. Secondary has 2 substituents. Tertiary, it has 3. Okay, I think that'll do it. That's a nice introduction to alcohols. Hopefully, I believe there's some practice with alcohol naming. It's basically naming as we know it, except paying attention to the parent chain is now in anol. We looked at some physical properties, namely the boiling point, and then we looked at how to classify each of these as primary, secondary, and tertiary. What we'll do going forward is looking at some chemical properties, some common chemical reactions these things undergo, recognizing that a great way to make these things is with the Grignard reaction. And then after that, the common class of reactions will be oxidations of alcohols.